Alright, so in this video we're going to go over this problem from our problem set here. Okay, so it says v of t is the velocity in feet per second of a skydiver at time t seconds, where t is greater than or equal to 0. After a parachute opens, her velocity satisfies this differential equation with initial condition v of 0 equals negative 50. Use separation of variables to find an expression for v in terms of t, where t is measured in seconds. All right, so that's probably the problem that takes the most work. So let's jot down our differential equation again. Now I'm actually going to factor out a negative 2 here and express it like this. And the reason I'm doing that is because, they're asking you to use separation of variables. Notice that our derivative is only in terms of v. There's no t in there. So what that means is really we got to get the v plus 16 on the same side as the dv, but the dt, I like to stick with this constant of a negative 2, right? There are no t's. So you can, there are a couple of options for this, but I'm going to, write it like this. I'm going to multiply both sides by dt and divide both sides by v plus 16 to end up with this. Okay, so that's what they mean by separation of variables. So now we're going to anti-differentiate both sides with respect to their variables. The left side, just be careful, in general, the antiderivative of v plus 16 is the absolute value of v plus 16. And the antiderivative of negative 2 is negative 2t, and I'm going to throw the constant in there. So the constant will take care of when we think about our initial condition. I think what I'll do first is convert this into exponential form. So e to all of this is equal to that. So I've got absolute value of v plus 16 is equal to e to the negative 2t plus c. A couple things. We know that this is equal to e to the negative 2t times e to the c. And we're allowed to call that just something else. I usually call it a. So now I'm going to call this a e to the negative 2t. Okay, and so then on the other thing to remember is that if the absolute value of something is something else, you can say this. However, you don't really need the plus or minus a, because a is just this constant that we'll figure out once we plug in our initial condition. So whether a is positive or negative we will determine that once we plug in our initial condition, which I'm going to do now. So v of 0 is equal to negative 50. So if v of 0 equals negative 50, clearly I like to change colors a lot. If v of 0 equals negative 50, that implies that when t is 0, the velocity is negative 50. So negative 50 plus 16 is equal to a e negative 2 times 0, which gives you a equal to negative 34. So I've got v plus 16 is equal to negative 34 e to the negative 2t, and subtracting 16 from both sides gives you what you want. Okay, so you can write it as a function of time, v of t. So there's part A. Part B asks for a limit. Let's see what it says here. Determine the terminal velocity is the limit as t goes to infinity of your velocity function. Find the terminal velocity of the skydiver to the nearest foot per second. All right, so we're doing a limit here. So the limit as t goes to infinity of v of t is the limit as t goes to infinity. I'm actually going to write it as negative 34 over e to the 2t, because that usually helps students see what that limit will go to. Right, so you want to imagine as t gets arbitrarily big, notice this denominator gets really big, and the expression itself, which I should have circled, I guess, separately. The expression itself will go to 0. So this should go to negative 16 feet per second. Okay, so there's A and B, and then C says It's safe to land when her speed is 20 feet per second. At what time t does she reach this speed? So just be careful because velocity and speed are separate concepts that are related. So speed is actually the absolute value of velocity. Right, so speed has no direction, even though velocity can. I mean, just note your initial velocity is -50, right? But speed does not have a direction. So if we want to solve this equation, right, when her speed is, we want to find when her speed is equal to 20 feet per second. So if the speed is equal to 20 feet per second, that means that the absolute value of our velocity is equal to 20 feet per second. And we'll just put in our velocity function up there. And we've got to solve this equation. So look, you can factor out a -1. Oops, did that a little too quickly, sorry. If you factor out a -1 here, you're left with 34e to the -2t plus 16. Right, but the absolute value of this is clearly just 34e to the -2t plus 16. Okay, now I think this problem is kind of an old school, so it looks like it's from 1997 actually. So you might have been expected to solve this by hand at that point, but I don't think at this point a calculator is probably fine. But we might as well just finish it off by doing it by hand. So that's, what is that, 4? Yeah, so now I've got divide by 34. So now I've got e to the -2t is equal to 2 over 17. And I'm going to write this in log form. So ln of 2 over 17 is equal to -2t. All right, just rewriting it in log form, and then we divide by -2. Okay, so it looks like at time ln of 2 over 17 divided by -2. Seconds, I guess it would be the units. Whatever that is in the calculator. All right, well, I hope that helped. It's the separation of variables probably requires the most technique. That limit question is good to get under your belt. And then this is just a reminder that speed is the absolute value of velocity. So hopefully that's helped you get through this problem.